In this video, we will talk about relative distribution of hardware-software cost, the definition of software engineering, and characteristic of software engineering. This figure is showing the relative distribution of hardware-software cost. We can see the cost of software is increasing and the cost of hardware is decreasing dramatically over time. At the early years, the programs were quite small and they were written by one person. Mostly they were written and used by experts in the application areas concerned. At the time, software was mostly developed by hardware vendors and given away for free. But present day, applications are rather different in many respects. We can see that present day programs are often very large and are being developed by teams that collaborate over periods of time, like several years. Now, it's not only the cost of developing the software. We can see it also the cost of keeping the software operational once it has been delivered to the customer. So, in the course of time, hardware costs have decreased dramatically, but now the hardware cost typically comprises less than 20% of the total expenditure, and the remaining 80% comprises all non-hardware costs, like the cost of programmers, analysts, management, user training, and many more. Moreover, if we talk about errors, we know errors in software may have very unfortunate consequences. So, the cost of software is of crucial importance. We can see from the figure that software maintenance costs around 50%. Why does software maintenance cost that much? We will study about software maintenance in details later. So now let's move to the definition of software engineering. What is software engineering? At an early definition, the definition was given at the first time at NATO conference in 1968, and the definition was that software engineering is the establishment and use of sound engineering principles in order to obtain economically software that is reliable and works efficiently on real machines. Um, this definition is actually pointing out to all the important things of software engineering, like the software should be economical, the software should be reliable, the software should work efficiently on real machines. And there is one more definition that's given in IEEE Standard Glossary of Software Engineering Terminology, and the definition is: software engineering is the application of systematic, disciplined, quantifiable approach to the development, operation, and maintenance of software, that is, the application of engineering to software. So there are different definitions of software engineering that use different words. But from those definitions, we can figure out the characteristics of software engineering. So here we have listed some characteristics of software engineering. The first one is software engineering is concerned with big programs. Software engineering concerns the development of large programs. At early age, programming was done in the small scale, but now we are doing programming in the large scale. We are not talking about programs that are written by one person in a relatively short period of time. Software development projects refers to large number of interrelated programs or components, and it's developed by many persons, and the time span of developing is we can say more than half a year. So software engineering concerns the development of large programs. The next one is complexity is an issue. The central theme is mastering complexity. Now the programs are big, but we can split the programs into parts such that each individual part can be grasped, while the communication between the parts remains simple. The total complexity does not decrease in this way, but it does become manageable. And the third one is software evolves. Yeah, most software model is a part of reality, such as tracking money transfer in a bank. So the reality evolves. It develops gradually. This means that costs are incurred after delivering of the software system, but we have to bear this evolution in mind during development. So yeah, software does evolve. So the next one is development must be efficient. Yeah, the efficiency with which software is developed is of crucial importance. Software engineering concerns better and more efficient methods and tools for development and maintenance of software. The next one is you are doing it together. Since the problems are large, many people have to work concurrently at solving these problems. Now we see that teams at different geographic locations work together in software development. So, regular cooperation between peoples is an integral part of programming in the large scale. So, yeah, we are doing it together in software engineering. The next one is software must effectively support users. So the question here is why we are developing the software. We are developing it in order to support users at work. So the software has to support its user effectively. Effective user support, these terms refers that we have to carefully study users at work in order to determine the proper functional requirements, and we must address usability and other quality aspects as well, such as reliability, responsiveness, and user friendliness. So we might have to write user manuals sometimes and training materials for easy understanding. So software must effectively support users. So the next one is involves different disciplines. Okay, software engineering is a field in which members of one culture create artifacts on behalf of members of another culture. Software engineering are talk about software engineers. So software engineers are expert in suppose in more than one area, such as programming in Java or software architecture or testing or the UML, Unified Model Language. They can be expert in more than one areas, but they are not generally expert in library management or banking, right? But yet they have to develop systems for them. They have to develop systems for those domains. So application domain knowledge is a common source of problems in software engineering projects. So finally we can say software engineering is a balancing fact. So the above list here, this list is showing that software engineering has many facets. Software engineering is not the same as programming. Yeah, of course, programming is an important ingredient of software engineering, but it has many more aspects. Suppose there are mathematical aspects. Since we are concerned with correctness of the software, so there are mathematical aspects, and also there are psychological and sociological aspects, because there exists communication between human and machine, organization and machine, and between humans, right? Finally, the development process needs to be controlled, which is a management issue. So all these terms, and utilizing all these terms, we can say software engineering hints at possible resemblance between the construction of programs and the construction of houses or bridges. So the question here is whether these kinds of resemblance do exist, whether we can say building software is equal to building bridges. We can say yes, as in both cases we work from a set of desired function and we use scientific and engineering techniques in a creative way. But we can also say no, and there are many reasons. If we talk about cost, the cost of constructing software is incurred during development, not during production. One more thing is copying software is almost free. Moreover, software is logical in nature rather than physical. Physical products wears out in time and therefore have to be maintained. Software does not wear out. There are additional reasons for considering the construction of software as something quite different from the construction of physical products. So in the next video, we will talk about software lifecycle. Thank you.